Thank you for still being here. I think it was a very, very good first day for this edition of PremDay. I'm quite happy on my side. Let's go. So I will start with a question. Who has already faced this situation? Your monitoring tells you that everything is fine, and your users are complaining because there is something very strange on the kernel console of your server. That happens quite often. So, monitoring is hard. I already told it this morning, but yes, it's true. And often, if you want to do something precise, you need to aggregate multiple data sources. More data sources is more information. And so, inbound monitoring and outbound monitoring are two complementary techniques to reach to real, to be sure that the hardware is working or not. We're going to talk about inbound monitoring here, and the kernel is a good place to get this information. It's at the interface between the software and the hardware, and it has a ton of context regarding what's going on. You can see that there was a ton of context, interesting context for debugging an hardware issue in this kernel trace. And so it would be nice if we could have that in some other forms than, just some text that is being pushed to the kernel console. Is there an API to get that? Well, the answer is no, not really. But the kernel has an interesting facility. It has trace points. So I'm going to be quick. I'm sure that many of you in this room know what it is. The kernel has a different strategic place. It has hook points where you can hook into and get information about the context that the developer that has put the trace point has given to that trace point. It logs structure information, so it's not text, it's really arguments, with very low level or very low overhead. And there is an API to access it, ftrace. You can see on the example how to do it with your console, but we can do it from a real programming language also. And so the idea for hardware errors is there are many, many code paths dealing with hardware errors in the kernel, and they often include trace points. So why not use them? Actually, some programs are using them. I don't know if you know the RAS daemon. That's kind of the new generation that supersedes MC log. And it kind of do that. At the moment, it doesn't do anything real useful with this information. It just prints it back to the syslog. So you are kind of going back in circle. But still, that's an interesting way of doing things. And that's how we want to do it at Criteo. But we want a bit more flexibility. The trace points argument, they are fixed. So what if you want, a bit more context? Do you recompile your kernel, adding, arguments to trace point and push that to production? Of course not. That's not how you do stuff now. You can use, BPF for that. I guess also it's no surprise for everyone in this room, but BPF, that's the low-level virtual machine in kernel, and it gives you the ability to hook small programs and attach them to trace points or functions in the kernel, and error function especially. And it can be used to create our own context. So the idea is really to have this kind of pattern when you put a flight recorder, just like in a plane, you put a flight recorder in your kernel, you attach a small BPF program that, just collects information, does not necessarily push that to user space. And when a trigger, a trace point, or an error function is called, you've hooked that, it triggers, and you emit a lot of important information to a user space program that tries to push that out to some central place to collect information for later analysis. And so that's the overview. That's what we are building. So we don't have the FAA daemon at the moment, but we are working on the flight recorder. Basically, we have a small program. It's for disk error at the moment, where we are Just, when there is a disk error, we are logging a little bit of information, and we are exposing that in a Prometheus metric format that we scrape for our servers. So you have a light version of the BPF program on the right. But that's the idea, and that's what we are trying to work on at Criteo. So I guess if it's interesting for you, feel free to come and talk to us about it. Thank you.
Do you have any integration with BMC systems? Like
Sorry.
Do you have any out-of-band integration with BMCs right now?
Right now, not really. Right now, we're just scrapping that, but the idea is really to, aggregate multiple metrics, those from the BMC and those from the. That was your question, or
My question was more. So I have a kernel error on my main processor, right? Something happened. BPF logs it. Does it have any way to transmit it quickly to the BMC right now?
So I think that's something that we could look at today with the current BMC. I'm not really, familiar with that, but I think on some proprietary BMC, some models, we can push information to the BMC. So that's something we could do. But I would say that's a very compelling argument for OpenBMC, where we could, customize the BMC and have this dual, or rather this codependency stuff.
Because essentially this is what already happens with hardware errors, with RAS errors.
Yeah.
You have IPMI messages that are sent, emergency messages that are sent to the BMC by the CPU. So this is kind of the same thing but higher level, which is interesting.
It is, yeah, but it doesn't exist today. Really, the kernel is not really doing stuff to the BMC. It's a bit more subtle than that, but basically it's not really used in practice. So, yeah.
Thank you.
Question here? No? Okay.
Well, thank you.
Thank you.